All right, number 5, this is a BC only question. Okay, I believe I didn't look at the AB to be honest, but not yet, but there's a Taylor polynomial and stuff, so that's BC, okay? So let's look at what this question says. Let y equals f of x be the particular solution to the differential equation, this guy, with initial condition f of 1 is -1. Part A, find f double prime of 1, the value of the second derivative of y with respect to x at the point 1, comma, -1. Show the work that leads to your answer. So we got to find the second derivative, so we implicitly differentiate, okay? So d squared y over dx squared is, we need the product rule. First, d second, so keep the first, differentiate the second. Derivative of y squared is 2y dy dx, okay, implicit differentiation. Plus, second, keep the y squared, d first, derivative of 3 minus x, just -1 with respect to x, okay? So that's the second derivative right there. Now we got to evaluate. At the point 1, -1, okay? First of all, we need the first derivative at this point, okay? Because we need to evaluate it in the second derivative. So we got to first get the first derivative, okay? The value at that point, okay? So we plug in into here the definition of dy dx. X as 1, y as -1. That's what it is. So you get 2, okay? Now the second derivative, where there's the x, we plug in 1. Where there's y, we plug in -1. Where there's a dy dx, we plug in the 2 we just found, okay? Do the math, you get -9. So the answer is -9. Okay? This is just implicit differentiation. So even A, B students can do this. All right? Now, part B, write the second degree Taylor polynomial for f about x is equal to 1, okay? So we just got to remember the formula for Taylor series, Taylor polynomial. So I noted it as T2 of x. I don't think you need to do that, but the formula is it's centered about 1, okay? So f of 1 plus f prime of 1 times x minus 1 to the first power over 1 factorial, should have it right there, plus f double prime of 1 x minus 1 squared over 2 factorial, okay? So we plug in the pieces, f of 1, that's -1, that's given. F prime of 1 was f prime of 1. We just found that in the previous part. That was, no, that was f double prime, sorry. F prime of 1, yeah, we've also found it in the previous part. That was 2 right here, okay? This is f prime of 1. And then x minus 1 we keep there. And then f double prime of 1, we found that as -9, so we keep that, okay? X minus 1 squared over 2 factorial is just 2. So here's the answer, okay? Part C, here's the totally BC topic. Lagrange error bound, or Taylor's inequality, that stuff. The second degree Taylor polynomial for f about x is equal to 1 is used to approximate f of 1.1. Given that the absolute value of f triple prime less than equal to 60 for x in the interval 1 to 1.1, use the Lagrange error bound to show that this approximation differs from f of 1.1 by at most 0.01, okay? So the tough part is memorizing the formula for this Lagrange error bound, okay? It's always confusing. So the error is less than or equal to, we got to maximize the next derivative, where n is the nth degree Taylor polynomial. So we got to maximize the next derivative within a certain interval, which they give us. Okay, so that's why I wrote it like this. There's lots of notations for these formulas, but I wrote it like this in this instance. But we want to maximize that. The n plus 1 factorial is always there. And then we also have to maximize this x minus 1 to the n plus 1, okay? So let's go through the pieces. It's basically the formula, okay? So as I said, we got to maximize the third derivative within this interval. So they just gave us that right there as 60, okay? And then we got to maximize this, okay? Basically, this is the maximum distance from the center, okay? So if you think about it, if x is 1, it's zeros, right? So it's going to be 0, so we don't want to pick that. The maximum will be when x is 1.1 within this interval. It's convenient that gives the interval actually as well, okay? So we keep x as 1.1 over here, okay? And again, the whole idea is we always want to overestimate errors. So that's why we maximize these two guys. We never want to underestimate error. In the real world, I always say this, if you say there's a maximum of 10% error, let's say, and then your thing actually has 20% error, your customer is not going to be happy about that. They'll complain, they'll sue you, and all that. So you have to always overestimate your error on the safe side, okay? So we plug in the two things and we start simplifying because we got to show that's at most 0.01, so we have to simplify here. 60 over 3 factor. What's 3 factorial? That's just 3 times 2 times 1. So 3 times 2 is 6. Okay. 1.1 minus 1 is 0.1. 0.1 cubed. That's 1 over 1,000. Okay. And then 60 over 6 simplifies to 10. So that simplifies finally to 1 over 100, which is 0.01, which is right there. Okay. We got better. Be able to memorize the formula, and we got to be able to use it. Okay. Honestly, in my opinion, memorizing the formula is the hardest part. Using it's not too bad, at least for me. Okay. Part D. Use Euler's method starting at x equal to 1 with two steps of equal size to approximate f of 1.4. Should have worked at least to answer. Okay. So it's easy to do, calculate the step in our head, but the way to do it is start or stop minus start, 1.4 minus 1 over the number of steps, so 2. So our step size is 0.2, okay? We start at the starting point, f of 1, that's given, that's minus 1. So now we take a step, so from 1, so that's 1.2. That's approximately equal to f of 1 plus f prime of 1 delta x. So f of 1, that's minus 1. What's f prime of 1? We found that earlier, right? In part A, that was 2. And then delta x is 0.2. So we got to simplify. That's minus 0.6. Okay. We technically don't have to, but this is easy enough. Okay. Now f of 1.4. Sorry, let me go take care of that real quick. Okay. Sorry about that. Now, f of 1.4, we take another step. So 1.2, take a step of 0.2, that's 1.4. That's approximately equal to the previous value, f of 1.2 plus f prime of 1.2 delta x. Okay, this is Euler's the procedure to do Euler's method. Okay, f of 1.2, that's minus 0.6, what we found previously in the previous step. F prime of 1.2, we got to find that. So f prime is dy dx. So we plug in 3 minus x is 1.2 because we want f prime of 1.2. Don't get confused, okay? And then our y was f of 1.2, which is 0.6 or minus 0.6, okay? 0.6 squared minus 0.6 squared, same thing, okay? Minus 0.6 inside the parentheses. And then times delta x. Don't bother simplifying this. You don't have to simplify, I believe, on the AP exam anymore. This is way too risky to simplify, so don't do it, in my opinion. Just keep it like this. Okay, that's it for this question. Hopefully the Lagrange error panel was not intimidating. It's actually, in my opinion, quite simple, as long as we have the formula memorized. That's the, honestly, in my opinion, again, the hardest part. All right. Hopefully I'll see you in another video of mine as well. Please give this video a like if this has helped you in any way.